Hi there, I am Namrata Naik. I'm an assistant professor in mathematics at P.E.S. College of Arts and Science, Famagudi, Honda, Goa. Well, I'm gonna talk about something today which we have been looking at since the childhood. Yet, if questions related to it are asked in the exams, then we are unable to answer them. Maybe because of lack of observation. This is something very trivial which we fail to notice, maybe because we never thought that something like this will ever appear in the exam and that too worth, say, 3 or 4 marks. No worries. Now is the time to start noticing or observing it, and I'm here to help you with that. To begin with, a clock is a circular device provided with three hands, which are an hour hand, a minute hand, and a second hand, and the study of it is known as horology. Now, this is something that you all know. Till now, we have been looking at it to know the time, but for the next 1 hour, our purpose will be different. That is, for the next 1 hour, we will be more interested in knowing the angle between any two hands in the clock than the time shown by the clock. So let's begin with the mission. Look at this figure on the screen. In total, there are 12 divisions, bigger divisions on this clock, these divisions. And between any two bigger divisions, we have the smaller divisions. There are what? 5 divisions. Okay. So in total, there are 12 divisions in a clock, which are nothing but what? Are hours. And the smaller divisions, between any two consecutive hours, we have 5 smaller divisions, which represent nothing but what? The minutes. Okay. So in total, we have 60 minutes, that is 12 into 5, that is 60 minutes, and total 12 hours in the clock. Now suppose I want to find the angle between this and this. That is what, if my one hand is at 12 and the another hand is at this point, then what is the angle between the two hands? This is what I want to find, suppose. Or suppose my hand is at 12, one hand is at 12 and the other hand is at 1. Then suppose I want to find that angle between the two hands. Then how do I find that? Okay. So we will see that here. All of you must be knowing that in a circle, the total count of angles is 360 degrees. So if I want to find the angle between this line and this line, that is this angle, then how do I find that? Before that, we will try to find the angle between the two hands if one is at 12 and the other is at 1. That is what, if suppose my hand is in this position. Then, what is the angle between this hand and this? That is this angle. Now, how do I find that? So, here, the total angle around this point is, this angle is 360 degrees. Okay. And, if I want to find this angle, now if you have noticed, here, this total angle is divided into the 12 subparts. Okay. So, and which are what? Equal. So, here, if I add this angle and suppose I have another hand over here, then this angle plus suppose there is this hand at 3, then plus this angle. All these angles will sum up to give me this 360 degrees. Okay. So, in order to find this angle or any angle between the two hands, if one is at a position, fixed position, and the other one is at the consecutive R or the R next to the fixed position R, then what is that angle? How do we find that? Just by doing the simple calculation, that is 360 degrees divided by 12, because there are total 12 divisions in the clock. So what do we get? 360 degrees by 12. Now 12 3s are 36 and 0. Therefore, we have 30 degrees. So that is what this angle between 12 and 1, if the hands are at these positions, then this angle is 30 degrees. Similarly, if my one hand is pointing towards 11 and the other hand is pointing towards 10, then the angle between the two is again 30 degrees. Okay. So now if we get back to our old question, previous one, that is, what is the angle between this one and this one? That is what, if my one hand is at this position and the other hand is at this position, then what is this angle? Now how do we get that? What we know, just now we found that the angle between this, if one hand is over here and the other hand is pointing towards 1, then this angle is 30 degrees. Now if I want to find this angle, suppose, then how do I find that? If you look at this, for this angle, total how many divisions are there? 1, 2, 3, 4, and there is one more here which cannot be seen here, but there are total 5 divisions. If you look at this here, between 12 and 1 there are 1, 2, 3, 4, 5 divisions. Okay, and this angle is in total 30 degrees and we have these 5 divisions. So, and these are equal divisions. Okay, so if I want to find this angle between these two, or this angle suppose, or this angle, they'll all be the same. Okay, now but what is that angle? How do I get that? In total this angle is 30 degrees, so we divide it by 5 as we have done earlier. Okay, in the previous one what we did is we divided the total angle 360 degrees by 12 divisions and we got 30 degrees. Now we have this 30 degree angle and we divide it into 5 parts. Therefore 30 degrees divided by 5, that is 6 degrees. So what we get? This angle is 6 degrees. So this angle is 6 degrees, this angle is 6 degrees, this is also 6, this one is also 6, and also we have another one here 6. The total counts to 30 degrees. Therefore, now what is this angle then? 6 plus 6, 12. Then we have 18. Then we have 24 and 30 as shown above. So each minute counts to 6 degrees and each hour counts to 30 degrees. These are the two very important things which may be asked in the exam. So you have to remember that between any 2 minutes the angle is 6 degrees and between any 2 hours, consecutive hours, the angle is 30 degrees. Let us look at some of the properties of the two hands. Beginning with the first one, it says the hour and minute hands meet only 11 times in 12 hours. Now first, in order to understand this, first we should know when do we say that the two hands meet. So let us look at this. Suppose the clock shows 12 hours, then the two hands will be positioned at 12. So how does it look like? See, my minute hand is this, then it is positioned at 12. Also my minute hand will be positioned at the same place. So if I want to find the angle between the two, then what will be the angle? The angle will be 0 because both of them are positioned at the same hour. Okay, so when do we say that the two hands meet? When they make the angle 0 degrees. So if you look at this, between 11 and 12, can you guess when they will meet? So suppose at 11, the position will be this. Okay, so after 11, so as my minute hand moves from this here, this side, this will move to this. So after 11, they will meet at 12. So between 11 and 12, they meet only once. Now let us check when do they meet between 12 to 1. Now after 12 what happens? Now after 12 what happens? The minute hand moves in this direction. So after 12 it just keep on moving in this direction. And what happens to the hour hand, which is again at the same position? It moves from 12 to 1. So once the hour hand reaches here, what happens? Now here at 1 o'clock, this minute hand moves this in this direction and then get back to this. At that time, what is the time that the clock shows? It is 1 o'clock, right? So if you have noticed, between this 12 to 1, the minute hand and the hour hand, they do not meet. That is after 12, they do not meet. So between 11 and 1, how many times do they meet? Just once. Okay. Now after 1 o'clock, when do they meet? So once this is at this position and this is at this position, the hour hand is at 1 and the minute hand is at the 12 position. What happens after that? This will again move in this direction and then reach somewhere here. Also this hour hand will move in this direction and finally at somewhere around after 1 they will meet at this position, right? So what happens here? So here they happen to meet. Again what will happen? The minute hand will move in this direction. The hour hand will move in this direction. And then what will happen? At 2 o'clock, what will happen? The minute hand will be over here and the hour hand will be over here. Let me change the color. Let us take this color. So at 2 o'clock, what happens? The minute, the hour hand is at this position. The minute hand is at this position. So after 2, what happens? Again, this will move in this direction. Then this will slightly move and will come over here. So after 2, they will meet somewhere here. So again, they meet between 2 and 3. The same thing will happen between 3 and 4 and 4 and 5 and so on. So in between any 2 consecutive hours, they will meet once. But between 11 to 1, they meet only once. So if we count the total number of times the minute and the hour hands meet will be equal to 11. That is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then between these two, it will be 11. Okay. If you find this difficult to understand, then don't worry, because mathematics makes the things simple. Okay, because we have a formula in mathematics which on application will tell you exactly how many times do the minute and the hour hands meet, or they are perpendicular, or they are exactly opposite, or they make any given angle between any 2 hours. Okay, so for that we have a formula and that we are going to learn further. So we have the property that the hour and the minute hands meet only 11 times in 12 hours. That is, they meet in between any 2 consecutive hours from 1 to 11 just once, and between 11 to 1 they meet only once, that is at 12 hours. So we have this. Similarly, we have 2 more properties which say the hour and minute hands are exactly 11 times exactly opposite to each other in 12 hours. That is, now what is exactly opposite mean is that the 2 hands face in the opposite direction. So we have this. They become opposite only once between 5 hours to 7 hours. This you can check on your clock. Similarly, we have the next property, but the same thing you can prove using the formula that we are going to learn in the next few minutes. Similarly, we have the next property here. It says the hour and minute hands are exactly 22 times perpendicular to each other in 12 hours. Now, what do we mean by the perpendicular? Perpendicular means if the two hands make an angle 90 degree. So let us see how do they look. Suppose my minute hand is over here and the hour hand is over here, then the angle between the two, thus if it is 90, then they are said to be perpendicular to each other. Similarly, if they are facing in the opposite direction, if one hand, that is say minute hand, is pointing towards 9 and the hour hand is pointing towards 3, then this angle is 90 plus 90, that is 180. So they are exactly opposite to each other. Okay. Pardon me with my lines as they don't appear straight, but assume that they are straight. Anyways, we are going to learn a formula which will tell us exactly how many times the two hands are exactly opposite, or they are perpendicular, or they meet, or they make any given angle theta in a in certain hours. Okay, so we'll move on to that now. Suppose I want to find an angle between hour and minute hand. Though I have given you the method before, it looks simple, but it consumes time. But in competitive exams, we don't have much time. Now, how do we solve such problems? We need to have a formula. And that formula, I'm gonna give you here. An angle theta between hour and minute hand at x hours and y minutes is given by theta is equal to mod of 30x minus 11 upon 2y. Okay, now this is the formula that we were looking for. Let's look at an example wherein we can use this formula. So suppose I want to find the angle made by hour and minute hand at 4 hours and 9 minutes. That is, the clock shows this. The hour hand is at this position and the minute hand is at this position. That is, I want to find this angle. Now, let's see how to use the formula that we have with us. The formula says that the angle theta between the hour and minute hand at x hours and y minutes is given by theta is equal to this, 30x minus 11 by 2y. Now here the only thing that we need to identify is what is my x and what is y. If I have x and y, then I can easily find out theta. Now what is x and y? X and y, x represents the hours and y represents the minutes. So in the given problem, what we are supposed to find is that x and y. That is, here now in the given problem we are supposed to find the angle between the hour and minute hand at 4 hours and 9 minutes. So this is my x, 4, and 9 is y. That is, so we have x is equal to 4 and y is equal to 9. Therefore, substituting this in the given formula, we get theta is equal to this, which on simplification gives us this, which on further simplification gives this, that is equal to this. And therefore, we have those who don't know how to get this from this. Suppose I want to find, or I want to divide 141 by 2. Now that is what? 7, 2 7s are 14. That gives me 1 here, and therefore here else goes 0, because here I have 1 point and there is another 0 will come here. So we are not interested in what comes after this decimal point. So here if you look at this, the complete integer that goes here is 70. Now therefore when I divide 141 by 2, what I get is, this is called the quotient and this is called the remainder. So here 141 divided by 2 is equal to 70 into 2, that is 140 plus 1. That is what, whenever we write, whenever we divide a dividend by a divisor, this is called the dividend, this is called the divisor, then this one is equal to, the dividend is equal to divisor into quotient plus the remainder, that is 141 is equal to 70 into 2 plus 1, that is 70 into 2, we multiply this 2 plus 1, that is 141 divided by 2, that is what we get. Okay, so this expression over here expresses nothing but, when I divide 141 by 2, the quotient, that is this part, is written over here. Then here we have the remainder, and thus it's something that we divide the number with. Okay, therefore I have 141 divided by 2, that is equal to 70 and half. So therefore, what is the angle made by the hour and the minute hand when the clock shows 4 hours and 9 minutes is that 70 and half degrees. Therefore, this is our solution to the given problem. Let's look at another problem of finding an angle between the two hands at a given time. Now suppose I want to find the angle between the two hands at the time 7 hours and 49 minutes. So again, using the same method, what I'll do is I'll identify my x and y. Now here x is 7 hours and y is 49 minutes. So therefore by substituting this in the given formula, we get theta is equal to 30 into 7 minus 11 by 2 into 49, which on simplification gives me this, and therefore this is some basic mathematics, just subtraction of two fractions, and then I get this. Now here I have a modulus sign here and there is a minus sign inside, so on taking the modulus we get the positive one. Now I have skipped a step in between. Now here minus sign, how does it disappear? This modulus of minus 119 by 2 becomes 119 by 2, which on simplification gives me this. Now as I have shown in the previous problem, how do I get this? This is nothing but what? When I divide 119 by 2, what I get is, the quotient is 59 and the remainder is 1. Therefore 59 into 2 plus 1 gives me 119 and divided by 2. Therefore what I get is the angle between the two hands when the clock shows the time 7 hours and 49 minutes is 59 and half degrees. This problem is similar to the previous one. The only difference here is there is a minus sign appearing here which disappears on taking this modulus. Okay, and the rest of the steps are exactly as the previous one. Let us look at a different type of problem. Now suppose I want to find what is the time when the hour and minute hands make an angle theta between A to B hours. Now for example, suppose I want to find when the hour and the minute hands make an angle 90 degree in the clock. Now if you look at the clock as shown here, now suppose I want to find what is the time when the two hands, the hour and the minute hands, make an angle 90 degree. Okay, now 90 degree, that is what, the two hands are perpendicular. Now suppose the clock shows the time 3 o'clock. Okay, then what is this angle? We all know that this angle is 90 degree, that is they are perpendicular. Similarly, it may so happen that if the hands, one hand is over here, that is what, the minute hand is over here and this hand is over here, then what happens? Again the angle is 90 degree. Again suppose one hand is at this position and another hand is at this position, again it is 90 degree, right? Again this angle is 90 degree as well. Also there are so many more possibilities, that is one hand is at this position and the other hand is at this position, again this angle is also 90 degree. Okay, so now if we look at the question here, that is, it says, when do the R and minute hands make an angle theta between A to B R's? That is what, suppose I want to find when do the two hands make an angle 90 degrees between, say, 2 to 3 hours. Then what will be your solution? The clock here. So we will look at this. At 2 o'clock, what happens? The hour hand is in this position and the minute hand is in this position. And then this minute hand moves in this direction. Okay. So what happens? As this hand moves in this direction, this hand also moves in this direction. Okay. So here, as this moves in this direction, it do not, these hands do not make angle 90 degrees. Now what happens? And then this will keep on moving in this direction, and then what will happen? At, say, when the minute hand reaches somewhere around here and the hour hand is somewhere over here, the two will make the angle 90 degrees. Okay. Now some of you might be wondering how this angle is 90 degrees. But no worries, because that's exactly what mathematics does. It gives proof to everything what we speak and hence gives the meaning to it. So we are going to prove that this angle is 90 degree. That is what we are going to find, what is the time between 2 hours to 3 hours when the two hands make the angle 90 degrees. And to our surprise, we may find more than one time instances wherein the two hands make an angle 90 degree between any given two hours. So let's look at the formula. It says, the time at which the hands make an angle theta between A to B hours is, now here assume that my B is the consecutive R, that is R next to A. If A is say 3, then let B be 3 plus 1, that is 4. That is, let B be A plus 1. If it is anything other than A plus 1, then we can just modify our formula accordingly. Okay, now here if I want to find the time at which the two hands make an angle theta between A to A plus 1, then obviously the R in that time will be A, and we only need to find is M here. So here we need to find the formula to find M, which is given by this. M is equal to 2 by 11 A into 30 plus or minus theta. Now this is exactly the same formula that we have used in the previous two problems. Just a simple modification. Now this plus and minus sign appears because we had that modulus sign in the previous formula. Now but no worries, you can remember this formula or you can just modify from the previous one, but I'm not going to get into that detail here. So here what we have is M is equal to this. So the time at which the two hands make an angle theta between A to A plus 1, say hours, is A hours and M minutes, where M is given by this formula. Okay, so we will look at some of the problems how to use this formula in order to find that time. Look at this problem of finding time at which the two hands meet between 4 to 5 hours. That is what I need to find the time after 4 and before 5 at which the two hands meet or the two hands coincide. Now, by applying the previous formula that says the time at which the hour and minute hands make an angle theta between A to B hours is given by A hours and M minutes, where M is given by this formula. Now, in order to apply this formula, what we need to know is what is theta, what is A and B. And if we know this, then we can find M. Now, in the given problem, what we have is this. We are supposed to find the time at which the two hands meet between 4 to 5 hours. So if you look at this, here A is 4 and B is 5. Now how do I get this theta to be equal to 0? Here the term meet is very important. Meet means what? The two hands coincide, and when two things coincide, the angle between them is 0. Therefore we have theta to be equal to 0. Hence what we get is this. M is equal to, on substitution, we get this. That is on simplification is equal to this. That is on further simplification gives us this, and that is equal to this. Now again let me tell you, here when I write this means what? This is something that we obtain as quotient when we divide 240 by 11, and this is the remainder. That is what, upon dividing 240 by 11, the quotient we get is 21 and the remainder is 9. So 21 into 11 plus 9 is equal to 240. Therefore, what is the minute M at which the two hands will meet after 4 hours? That is 21 minutes and 9 by 11 seconds. That is, they meet at 4 hours, 21 minutes and 9 by 11 seconds. Let us look at another example. We are supposed to find the time at which the two hands are exactly opposite to each other between 7 to 8. Here, in order to use that formula, we need to identify A and theta. If you look at this problem, A is 7 and B is 8. And what is theta? The question says that the two hands are exactly opposite to each other, and I have told you earlier that when do we say the two hands are exactly opposite? When the angle between them is 180 degrees. Therefore we have this theta to be equal to 180 degrees. If you look at this formula, there is this plus and minus sign before this theta. So this means that there are two possible candidates for the solution, that is for M. So we solve this problem by taking plus theta first and then minus theta. So what we get is M is equal to, so first we will proceed with plus theta. So on substituting and simplifying, we get this, that is 70 minutes and 10 by 11 seconds. But if you look at this, 70 minutes makes it what? 1 hour, 10 minutes and 10 by 11 seconds. So it crosses 8. But we are interested in what? The time between 7 to 8, where the two hands are exactly opposite to each other. So we discard this as it crosses 8. And therefore, the next one we have taking minus theta, which on simplification gives us this. That is 5 minutes and 5 by 11 seconds. Therefore, the time between 7 to 8 when the two hands are exactly opposite to each other is 7 hours and 5 minutes and 5 by 11 seconds. That is On this watch, it will show the hour hand will be somewhere here and the minute hand will be somewhere here. That is what? Between 7 to 8, this is the time when the two hands are exactly opposite to each other. That is, this angle is 180 degrees. Let's move on to the next one. When would the two hands be perpendicular to each other between 1 to 2? That is what. Now here the angle is what? Perpendicular means what? The angle is 90 degrees. And my A is 1, B is 2, theta is 90 degrees. So on applying the formula, what we get is this. So again, we have plus theta and minus theta. Now here theta is not equal to 0. Therefore, we will have two possible candidates for M. M is equal to, first, plus theta gives me 21 minutes and 9 by 11 seconds. Therefore, they will be perpendicular at 1 hour, 21 minutes and 9 by 11 seconds. And the second candidate is M is equal to this and minus theta. Now here the next step here after this is very important. I can't have M to be negative because minutes cannot be negative. There is no negative business here. So I need to get rid of this minus sign here. And also I don't have a modulus here. So what do we do is we add this negative quantity to the total count of angle. That is what? 360 degrees. So what we have to do is, this is a very important step. You need to remember this. If you get a negative theta or negative value in the problem, then what you have to do is you have to just add that value to the total angle, that is 360 degrees. So if I add minus 60 to 360, then what I get is 300. So and then on simplification, we get 600 by 11, which in turn will give me 54 minutes and 6 by 11 seconds. So they will be perpendicular again at 1 hour, 54 minutes and 6 by 11 seconds. Now here if you look at both the solutions, this one is at 21 minutes past 1 and this one is at 54 minutes past 1. Both are between 1 and 2. So both are the solutions. That is, between 1 and 2, the two hands will be perpendicular twice. That is, first at 1 hour and 21 minutes and 9 by 11 seconds, and the second time they will be perpendicular when the clock will show 1 hour 54 minutes and 6 by 11 seconds. I have an exercise for you. I want you to find when would the two hands meet between 5:30 to 6. Okay, now this is slightly different from what we have solved before. Here A is not in terms of hours, exact perfect hour. This is 5 hour and 30 minutes. So what you will do in this case? The procedure remains the same. That is, here A will be same 5. Okay, and you are only supposed to find M as we have done in the previous case. Now here theta will be 0 degrees. Next, look at mirror image time. Suppose I am given a clock and a mirror is placed in front of it. Therefore, I'll get a image here. Now I want to know what is the time that is shown by this clock in the mirror. We have a formula for that, which is given by mirror image time plus real time is equal to 11 hours and 60 minutes, that is same as 12 hours if the time is between 1 to 11, and mirror image time plus real time is equal to 23 hours and 60 minutes, that is same as 12 hours if the time is between 11 to 1. Here, what is the time that is shown in this clock? It is now here the hour hand is at 4 and the minute hand is at 5. So this clock shows 25 minutes past 4. Let us try to use this formula now, whichever that is applicable to the current problem. Let's try to find the time that is shown in the mirror image of this clock. That is this. If you look at this, one can easily tell that this is 35 minutes past 7. Let's try to get it from the formula. See why these formulae are used here is that one wants to be sure in the exam, because in the exam what happens is our mind is disturbed or it's nervous. Okay, so in order to be sure or in order to verify whatever we have obtained just by looking at your watch, you can get the answer. Still, in order to verify it or in order to confirm the solution, we have to make use of this formula. So let's try to make use of one of these formulae, whichever that is applicable here, to know what is the time that is shown by this clock. That is, if the time in the clock shows 25 minutes past 4, then what is its mirror image, or what time will the mirror image will show. So let's look at this. Now here the time is between 1 to 11. So we make use of the first formula. Mirror image time plus real time is equal to 11 hours and 60 minutes. That is 12 hours. Same as this. On substituting, I get 35 minutes past 7. That is 7 hours and 35 minutes. Next, look at this problem. The time in a clock is 17 minutes past 11. I need to find the mirror image time. Here, the time is between 11 to 1. Therefore, we use the second formula. That is, mirror image time plus real time is equal to 23 hours and 60 minutes. That is 24 hours. Which on simplification and substitution and simplification gives me 43 minutes past 12. Therefore, the mirror image time is 43 minutes past 12 when the real time in the clock is 17 minutes past 11. Now let's see what if the number of mirrors is more than just one. So first we have a clock, we place a mirror in front of it and we get its image. So if there is one mirror, we get the mirror image, one mirror image. Now again, if suppose before this mirror image another mirror is placed, then we get its image, which is nothing but the original one. So if there are two mirrors, then the time that is shown by the clock is the real time. Now again, if I place one more mirror here, then what I get is the mirror image time, same as what we get when only one mirror is placed. Now again, if I increase my number of mirrors, I get the mirror image, then again another mirror, and we have the mirror image of it. So here, when I have 1, 2, 3, 4, 5 mirrors, what I get is the final output that we obtain here is same as when we have only one mirror in front of the clock. And if suppose I have 4 mirrors, then the mirror image that is obtained is same as the original one. So now you must have got that if the number of images, if the number of mirrors is is an odd number, then the image that is obtained is same as the mirror image obtained when there is only one mirror. And if the number of mirrors is an even number, then what we get is the original clock. Therefore, when there is an even number of mirrors, we get the mirror image time is same as the real time. And when there is an odd number of mirrors, the mirror image time is the mirror image time obtained when there is a single mirror in front of the original clock. Let's look at water image time. Now suppose I have a clock and there is a water surface here, and we get the water image here. So if the original clock shows this time, that the water image will show this time. Now again, like in case of mirror image, we have a formula to get the water image time of a clock, which is given by this. Water image time plus real time is equal to 18 hours and 30 minutes. Here, this formula is applicable if minutes in the real time are less than or at most equal to 30. If they exceed 30 minutes, then we have this formula that shows that says water image time plus real time is equal to 17 hours and 90 minutes. Though this is same as 18 hours and 30 minutes, but in order to get the correct time in in order to avoid the negative business, we take this 17 hours and 90 minutes if minutes in the real time are greater than 30. Let's see some problems on this. The clock shows 25 minutes past 8 and we are supposed to find the water image time, or the time that is shown by its water image. Here if you look at the minutes shown in the real time are less than 30. Therefore, we use the first formula. Water image time plus real time is equal to 18 hours and 30 minutes. On substitution and simplification, we get 5 minutes past 10. That is, this is the time that will be shown by the water image of the clock that shows this time. Similarly, we have one more example here. Clock shows 39 minutes past 10. We are supposed to find the time shown by its water image. So here, if you look at the number of minutes in the real time crosses 30. Therefore, we use the second formula that says water image time plus real time is equal to 17 hours and 90 minutes, which is same as 18 hours and 30 minutes, which on simplification gives us this, that is 7 hours and 51 minutes. That is 51 minutes past 7 hours. Hence, we are done with the clock problems here. Let us look at what we have done so far. First, we obtained the formula to find the angle between the minute and hour hand, which is given by theta is equal to mod of 30x minus 11 by 2y. Then, the time at which the two hands make an angle theta between A and B hours is given by A hours and m minutes, where m is given by this formula, which is nothing but this, obtained by some modifications in it. The next one that we did is the mirror image time of a watch, given by this, and then the water image time. So hope this will help you crack the clock related problems in the competitive exams. Thank you.